This ice doesn't float. It sinks. And when it reaches the seafloor, entire colonies freeze alive. Scientists call it a brinicle, a frozen tube growing downward through the ocean itself. But the real anomaly isn't the ice. It's the liquid inside it. Because this water is so cold, it should already be frozen solid. Instead, it keeps moving. And anything caught beneath it freezes where it stands. The deeper scientists studied this phenomenon, the more it began to resemble something not just from Earth, but from the hidden oceans of alien worlds. So how can a liquid cold enough to freeze life remain liquid at all? To understand the brinicle, we have to look at the chemistry of sea ice formation. When the atmosphere above the Antarctic drops to -40 degrees Celsius, the surface of the ocean begins to lock into a solid state. But there is a problem: salt. The crystalline structure of ice has no room for sodium chloride. As the seawater freezes, the salt is forced out of the crystal lattice. This is a process known as brine rejection. The rejected salt doesn't disappear. It becomes trapped in tiny pores and channels within the ice sheet. Because of its high salinity, this brine does not freeze. Instead, it remains liquid, even as its temperature drops to match the freezing air above. This creates a paradox: a liquid colder than the water it's surrounded by, yet still flowing. The brine is now two things: colder and denser than the surrounding ocean. Under the laws of gravity, it has only one direction to go. It begins to leak. It begins to sink. As this ultra-cold, hypersaline brine leaks from the ice sheet, it encounters the fresh seawater below. The interaction is immediate and irreversible at a molecular level. The brine is so cold that the moment it touches the surrounding water, that water freezes instantly. But it doesn't freeze into a solid block. Because the brine is constantly flowing downward, it acts as a drill. It freezes a delicate, hollow sheath around itself. It creates its own pipe, an architectural shield of ice that insulates the cold brine from the warm ocean. This is the birth of the brinicle, a hollow tube of ice through which a lethal, sub-zero current flows. The physics of this system is a delicate balance. If the flow is too slow, the pipe freezes solid and the pulse stops. If it is too fast, the ice sheath cannot form. At this moment, the system is in a state of temporary stability. It is a gravity-driven descent of absolute cold, protected by a fortress of frost. And this is where the system stops behaving like ice and starts behaving like a weapon. In a typical environment, fluids of different temperatures eventually mix and stabilize. But the brinicle is a system that behaves as if it cannot reach equilibrium. The ice sheath prevents mixing. This allows the brine to retain its lethal temperature all the way to the seafloor. This is a state of gravity-driven instability. As long as the ice sheet above continues to grow and reject brine, the finger will continue to descend. It is a one-way transfer of thermal energy. For the organisms on the seafloor, sea stars, urchins, and anemones, this is a threat they are not evolved to perceive. They move in minutes. The brinicle moves in seconds. It is not a predator with intent. It is a failure of the environment to remain stable. A localized collapse of the life support system of the deep ocean. But the descent is only the first phase. The true devastation begins when the finger touches the solid ground. When the brinicle reaches the seafloor, the brine doesn't stop. It pools. It spreads. It creates a river of death that flows along the contours of the earth, freezing everything in its path. Molecules freeze in place. Biological processes stop mid-cycle. For decades, we thought this was a rare Antarctic anomaly. But as we explore deeper into the physics of ice, we realize this mechanism might be the key to understanding something much larger. What happens when this ice finger touches a biological colony? And if this process happens in our oceans, what does it tell us about the subsurface oceans of the outer solar system? To find the answer, we have to follow the river of death to its final destination. When the Brinicle touches the seafloor, the vertical descent is over, but the expansion is just beginning. It does not simply stop. Because the brine inside the tube is denser than the surrounding water, it continues to flow. It pools at the base and begins to creep along the contours of the sediment. This is the transition from a column to a cryogenic sheet. As the superchilled brine spreads, it freezes the top layer of the seafloor instantly. The silt, the pebbles, and the organic matter are locked into a solid, white pavement of ice. This is a horizontal expansion of absolute zero. It moves slowly, almost gracefully. But in the world of the deep Antarctic, speed is relative. For the organisms living in this high-pressure, near-freezing environment, the Brinicle is a high-speed catastrophe. On the Antarctic seafloor, life exists in a delicate metabolic balance. Sea stars, urchins, and anemones operate at a pace dictated by the extreme cold. They move in millimeters per hour. The Brinicle moves in centimeters per minute. This is not a hunt. It is a byproduct of physics. As the ice web reaches these organisms, the water inside their tissues is subjected to an impossible gradient. The brine is so cold that it triggers intracellular freezing. The biological cost is total. The ice crystals pierce the cell membranes from the inside out. In a typical environment, a predator consumes its prey to transfer energy. Here, the Brinicle consumes life simply because it is an obstacle to thermal equilibrium. By the time the brine passes, a graveyard of crystalline statues remains. Thousands of organisms, perfectly preserved in a state of cryogenic arrest. They are not just dead, they are structurally integrated into the ice sheet. But the temperature isn't the only weapon. There's the salt. The brine flowing through the Brinicle is hypersaline. Its concentration of sodium chloride is far higher than the internal fluids of any marine organism. When the brine surrounds a sea star, it initiates a massive osmotic shock. The salt draws the water out of the biological cells in a desperate attempt to balance the concentration levels. The organism is essentially dehydrated while being frozen. This dual threat of thermal shock and osmotic collapse ensures that nothing caught in the path of a Brinicle survives. This is a state of systemic decimation, a localized event that can wipe out entire colonies in a matter of hours, leaving behind a sterile, frozen wasteland where a thriving ecosystem once existed. Why does this Antarctic anomaly matter to the future of science? Because the Brinicle is a terrestrial laboratory for the subsurface oceans of the outer solar system. When we look at the icy moons of Jupiter and Saturn, Europa and Enceladus, we are looking at environments that mirror the Ross Sea. They possess massive ice shells covering saline oceans. If brine rejection occurs on Earth, it almost certainly occurs on Europa. Scientists theorize that ice fingers may be a primary driver of thermal flux in these alien oceans. On Europa, Brinicles could be massive, extending kilometers down into the dark water, transporting chemicals and minerals from the crust to the seafloor. If life exists in those dark oceans, it likely faces the same cryogenic threat. We are learning that the physics of the Antarctic are the physics of the galaxy. To understand the ice finger of death is to understand the survival limits of the universe. The Brinicle eventually fades. When the seasonal cycle shifts and the surface air warms, the brine rejection slows. The finger becomes unstable, the hollow pipe cracks, and the system returns to the ocean's standard equilibrium. But the path it carved remains. The Brinicle is a reminder that in the most extreme environments on Earth, survival is not about strength. It is about the ability to exist within a narrow window of physics. We don't just inhabit this planet. We exist inside its thermal circuits. We are passengers on a world that purges its impurities with a cold, crystalline indifference. Stay curious, because the system does not adapt to you. You adapt to it.